Hi guys, so today we will solve this problem, coin combination 1. So the problem statement is, consider a money system consisting of n coins and each coin has a positive integer value. Your task is to calculate the number of distinct way you can produce the money sum x using the available coins. So for example, let's say if you have these coin values 2, 3, 5 and you want to make desired sum 9, so there are 8 ways. So these are given here, right? So the input format is also pretty much clear, that first we are provided with the number of coins, and in the next line there are the values of number of coins, and in the second value of the first line is the desired sum, and you have to output the number of ways to make that desired sum, and the number of ways can be too many. That's why we have to return the answer in the module of 10 raised to the power 9 plus 7. So this problem is very much similar to the problem which we have solved earlier, that was dice combination. But here, instead of in that problem we were having dice at every step we were including number from 1 to 6 when we have to build up the sum. But in this case, instead of this dice we have the coins, and the coins value can be vary, so that's why we have to take input of them, and they are not too many. At max value of the coins can be 100, right? The at max number of coins can be 100, right? So now we will solve this problem. So as we are discussing in this series, that whenever we are approaching a DP problem, we basically have to focus on these three things. So what will be your state of the DP, and what will be your base case, and what will be your transitions of DP. So I'll write now. So in the case of DP state, it's pretty much simple. Let's say if you consider I as your desired sum, right, and DP of I will be your answer. So your answer is basically total number of ways to make your desired sum, right? So this is your DP state. It's pretty much clear, there is nothing more to explain here. So in the case of base case, so let's say if you want to make some 0, so what will be the value of DP of 0? So it's also very intuitive that when you have to make some 0, you don't really need to choose any coins, right? So there is only one way to make some 0, that is you don't choose anything, right? So that is 1. The value of this thing is 1. DP0 is 1. That will be your base case, right? Now the most important thing, what will be your transition in this particular DP? So for transition, just look at this. Let's say if I want to find the answer for DP9, I want to find the answer for this, right? And the coins which I can play with are these. So what are those? They are provided in the sample test case. That is 2, 3, 5, right? 2, 3, 5. So 2, 3, 5, right? Now you want to make the answer for this, right? So how many ways are there so that you can reach 9? Consider that you have calculated the answer for values less than I. You have already calculated the answer for those. Now you just want the answer for DP of 9. So how many ways are there so you can reach 9? And you can only reach by using these coins, of course. So the number of ways that are to reach 9, that are DP9 minus 2 plus DP9 minus 3, DP9 minus 5, right? Now I will rewrite this line. That is basically DP7 plus DP6 plus DP4. So if you know the number of ways to reach here and this one, then you can build the answer for DP9. Similarly, when you have to find the answer for, let's say, DP7, you should know that how many ways are there to reach DP7 by just using these coins. Because let's say every time you are using some coins, we are just picking the last coin which we have used. So let's say you know the number of ways to get the desired sum 7. Let's say the number of ways, just assume that number of ways to make desired sum 7 is 5, and you can just use one more coin, that is coin number 2, coin whose value is 2. Then your sum from 7, it will become 9. So you can reuse those ways which you have calculated for making the desired sum 7. Similarly, you can reuse the ways which you have calculated to get the desired sum 6, because let's say if there are 2 ways to reach to the 6, just assume that if there are 2 ways to reach to the sum 6, you can just reuse those 2 ways and use one more coin, 3. That won't increase the number of ways, right? Similarly for the DP of 4, right? If you know how many ways are there to reach to the sum 4, then you can just reuse those ways and use one more coin. So that's how you can build up your answer. In a generalized case, let's say if I want to make the answer for I, what I can do, I will iterate through my coins dot size I plus plus. I will iterate through my coins, right? And every time I will just add this value. Let's say I know the answer for this thing, right? I know the answer for this. I can add this value and I can get the answer for DP of I. So this is the generalized way. And also you have to make sure that this index won't get negative, right? So now I will show you the code for the same. It's pretty much very much simple code. Yeah. So here I have taken the input for the number of coins and the desired sum which we have to make, and this is the input of the coin array, right? And now we have made a DP, and this is my base case. And now I will iterate through all these. Now I will build up my answer from I equals to 1 to n, because I need the answer for n, right? And every time when I iterate through this, I will initialize my answer for the DP I by 0, because initially there must be some garbage value there, right? So I should do this initialization because I'm using this array, right? Now I have to build up the answer for DP I. For doing so, the same thing which I have done here, same thing which I have done here, I'm doing this same thing here. I'm iterating through my coins. And also, if you guys don't know, this is the range based loop. So this is very much simple. You can use this thing, and your C will be the values of the values in this array coins, right? If you don't know about range based loop, you can just write in the comment. I can make one video for that. So I'm just iterating through the loops, and just believe me, this particular line is same as this line which I have written here, this one, right? So I will just iterate through the coins, and I'm seeing my index is not getting negative, right? And if it is so, then I'm just adding the pre-calculated ways for the I minus C, and every time I take the module of it, right? And finally I will just output my answer for DPN. So that was the code for this problem. And also check out my boilerplate videos. I'm making a complete playlist of CSES problem set. So first we are covering the DP section, and you can check out this playlist, and soon this playlist will get complete. I will be posting videos in bulk. Thank you.